Hi, I'm Mary Brady, and this is my Physics 2 Experiment 1 on charged tapes. The purpose of this experiment is to show experimentally and computationally the electric field of two objects of equal charge. The models I will be using are Coulomb's law, gravitational force, electric field, which is equal to electric force divided by a point charge, and Newton's second law, which states that net force is equal to change in momentum over change in time. The main result of this lab are that the tapes repel due to like charges, where the top tape moves up against gravity away from the bottom tape, showing that electric force is stronger than gravitational force, and also visually representing the electric field. The system is the top tape, and the surroundings are the bottom tape, and both tapes have the same charge. Both tapes have a length of 0.2 meters and have the same mass, and the distance when the tapes start to repel is 1 millimeter. I use the area of the tape and multiply it by the area of one atom to find that there are 4 times 10 to the 7 atoms in a piece of tape. And the electric force is pushing up on the system and the gravity is pushing down on it. And I find gravitational force to be 0.0196 newtons and electric force to be 1.96 times 10 to the negative 12 newtons. Since there is no change in momentum of tape B, I assume that gravity is equal to electric force. So I can derive the equation to find that the charge of the tape is 1.476 times 10 to the negative 8 coulombs. And I determined that the system has a positive charge because it was attracted to a negatively charged object. And using the charge of the tape, I divide it by the charge of a proton to find that there are 9.23 times 10 to the 10 protons. And in my first computational model, I used gravity, the Coulombic constant, my initial conditions, and I find gravity and electric force in order to find the point charge, which is 4.67 times 10 to the negative 10 coulombs. In my second computational model, the white arrow is electric force and gravitational force is the yellow arrow. And I use the magnitude of the point charge in part 1 to show that the charge being distributed across the tape, which is represented by these green arrows. And I found that the magnitude of electric force is 1.97 times 10 to the negative 7 newtons, and gravitational force is 1.96 times 10 to the negative 3 newtons, which is much larger than the electric force. And I found this by finding the electric field with this equation, the line charge with this equation, the vector representing the top and bottom tapes, and iteratively finding the electric force acting on the tape. So the charge of the piece of tape from my experimental data was larger than what I found in my computational model, so I might have made an error in my calculations. Both the experimental data and computational models were made under the assumption that the only forces acting on the tape were gravity and electric force. The second computational model found gravity to be stronger than electric force, which could be due to a small distance at which the tapes repelled in my experiment. My experimental data and my computational model found gravity to have the same value, but the electric force was much smaller in my experimental data than it was in my computational model, which could be why the charges I found were experimentally and computationally were so different. So some possible sources of error. My tapes lost charge very quickly in my experiment, which meant that my distance between the tapes might have been smaller than it should have been. And there also may have been more forces at play, such as air resistance. So what if protons were negative and electrons were positive? The tape would have had a negative charge since it has more protons than electrons, and therefore would repel other negatively charged objects and attract positive objects. And my first computational model was different than my second one because line charge model accounts for the superposition of the electric field. And the line charge would be closer to real life because it would simulate how charges are spread throughout a piece of tape. Thank you for watching.